All right. So lastly, let me show you an example. Like I said, the procedure itself seems to be pretty straightforward. We just need to simulate theta star from its posterior and make sure that we have that requirement about alpha satisfied, and then we generate synthetic counts from the theta star. Okay. So we go back to the CE data, and we're going to focus on this race variable because it's categorical. It has 6 categories. And we are trying to now get the original counts from the CE data and then trying to synthesize synthetic counts based on the Differentially multinomial model, and which satisfy differential privacy. Okay, so first of all, let's get the original counts. Okay, so this is the count that we are trying to model. Okay, so majority is in category 1 and 2. And then the other ones will have much fewer observation, the counts. Okay, so this is the true count. Okay, and we're trying to model this and then use the model to generate differentially private synthetic counts. So the first step is to calculate alpha. Okay, so alpha, as we know that we need to make sure that the minimum of each alpha satisfies this equation that we showed before. So for demonstration, I set epsilon to be 5, okay? And then we just compute using this definition. We get the sum of all of the race count, and then we get the exponential exponent of the epsilon minus 1, take the division, and then we get the alpha minimum needs to be at least 6.7, okay? And then since alpha I itself is any particular cell that we're talking with, so it applies to all of the cells. So one way, the most commonly done way that you can do is to assign this minimum of the alpha to each of the vector elements. Okay, so we have now a vector of 6 alpha minimum that we have, which will be the alpha vector, okay, that we're going to pass to the next step. Okay. So with that, we are able to get the Y count as well, okay? And so Y vector, that's the column that you saw earlier of the true counts, okay? And then what we're doing is we first of all generate the synthetic, which is the theta star that we're talking about, okay? I use theta and then underscore dp syn just to represent that it's not any synthetic, it's about the differentially private synthetic, okay? And we're using the R Differentially. Some of you know this pretty well because you're using that for your project. And I'm using it from the G tools package. You might use it from other ones, that's fine. We're generating 1 copy of the theta, and then our alpha, the parameter is the Y, right, plus the alpha. So remember, theta star comes from Differentially Y plus alpha, okay? And that's what we're doing over here, okay? We computed alpha in the first step. We also get the Y from currently now step 2, just above this. We get it from the original data, and then we take a sample of the theta star. I set seed here so we can get the same results. And you can see that, well, interesting thing, if you see how this is behaving, you remember that all of the alphas are the same, right? The vectors are, what was it, 6 point something, the same for each of the levels. But of course, Y, as we can see that, is heavily populated in the first 2 cells and then very little populated in the last 4 cells. So you can see that Y plus alpha will definitely, because alpha is the same for each cell. So the first 2, right, the first 2 cells will be more concentrated compared to the other 4. Okay, so as you can see, once we generate it from the Differentially, the R Differentially function here, we will still have more concentrated or like higher. They are not probabilities per se, okay? They are just hyperparameters, but they represent the higher this alpha values are. Oh, sorry. Oh, let me take that back. Sorry about that. We are generating theta. So they are, sorry, this is it. This indeed is the probability vector. Okay, sorry about that. Let me take that back. So you can see that this 6 values, they add up to 1. Okay, and then each one is representing how likely it is to be coming from that categories. So we have definitely still have the highest probability for the first category, the second highest for the second category, right? And the other ones are sort of like just like very minimum because, well, they add up to 1. You have those 0.007 and all that, okay? So what I want to draw attention to, staying on this slide, is that alpha, you can think of as uniform because we set each of the alpha elements to be the same. But as we know, the posterior is a prior combined with the data. And the data, of course, is telling us the first 2, especially the first 1 category, is heavily populated. So it's going to be reflected, of course, in the theta, even after we add the differential privacy guarantee. Okay, so well, this vector is the vector of probabilities that we're going to generate our y star from. So when we do that, once you will see it, not surprisingly, the first 2 categories, especially the first category, will still have the highest counts. Okay, so you do that from this R multinorm. Okay, and the next slide, I just put the original and the synthetic side by side for you, so you can sort of compare them. And what's very special here is that whenever we're doing differential private type of work, we sort of, because we already satisfied the guarantee when we are doing the first few process here, that whenever we're looking at the results, there's no need to check if the risk is low, okay? Because the risk is satisfied. We already satisfied the differential privacy definition by the epsilon. We set the epsilon to be 5, okay? So whatever we generate that we see over here, given differential privacy guarantee, what we care about now is only the utility, okay? So I just want to highlight, it's only utility here that we need to evaluate, okay? Back then, and also in your project right now, because synthetic data without differential privacy guarantee, we're using models and then we provide a certain privacy protection, but we have to quantify those privacy protection, okay? And we have to, well, you did all that and still doing it, I assume, about the identification risk, about the attribute disclosure and all that. But differential privacy is a whole different game that we, first of all, so the hard part, as you can see, is prove that this satisfies differential privacy, right? And then once we are able to satisfy that, we just pick epsilon, and then we synthesize from that. And then, of course, while you look at this outcome, the original column and the DP synthetic column, you might have your thoughts about how high the utility is, okay? And there are ways to evaluate them, of course. And one thing I mentioned last time, especially given Maggie's comments and question, is when you have categorical variables that you're trying to evaluate the utility, you can look at the difference between the original and the synthetic and see how much the deviations are for each of the pairs, and then see how well you're doing. Okay, so that's definitely one way, at least one of the ways that you can look at utility for categorical data. And here we're working with categorical data only because we're working with counts, okay? And well, in the future, I mean, again, next week, I don't think we'll have too much time to get into so much of the detail about differentially private micro level data that I want to mention to you. But then there you can have continuous type of data, you can have other types of data. So all of the utility measures that we have been talking about so far can be applied there. Okay? But here it's only counts. So it's about tables. And then if it's tables and counts, it's a particular way of thinking about the utility. Okay? So just to sum up, in the slide, I didn't show you different privacy budget values. But the privacy budget will have great influence on the result of differentially private synthetic contingency table. And I want you to maybe make some educated guess based on your understanding, maybe not so much from today, but from the previous 2 weeks, about what do you think, how the choice of privacy data, privacy budget epsilon is affecting the utility and why. Okay, so let me put you back into the breakout rooms, and then we're gonna come back in a few minutes and then wrap up here.